Hello, thanks for clicking, and welcome back to another Pre-Narculus production, another exciting event. Today, we are going to talk about section 7.4, which is partial fraction decomposition, which sounds like an extremely exciting and fancy topic. 7.4, partial fraction decomp for short, decomposition. Okay. All right. So let's talk about what partial fraction decomposition is. So let's start with something you already know how to do. So here's an example: 3 over x plus 2 plus 4 over x plus 1. I want you to find for me a common denominator and add these fractions together and make one fraction. So that you definitely know how to do. The first fraction is going to need an x plus 1, right, on top and bottom. And the second fraction is going to need an x plus 2 on top and bottom. Okay, so my common denominator will be x plus 1, x plus 2. In the numerator, I'll have 3 times x plus 1 plus 4 times x plus 2. I can distribute across the top here. And eventually, if I do it correctly, I'll get 3x and 4x is 7x, plus 3 and 8 is 11. So I get 7x plus 11 over x plus 1 times x plus 2. Okay, that is my combined fraction that I get, right, after I add these two fractions together. All right, so you all know how to do that, right? Everybody knows how to take these two fractions, combine them, add them, and get this answer. So what partial fraction decomposition is all about is it's the idea that you can start with 7x plus 11 over x plus 1 times x plus 2 and figure out which fractions you added or subtracted to get this answer. So what we're going to do is we're going to reverse everything that we've just done. How do you start here and go backward and get back to where we started again? That's what partial fraction decomp is all about. Okay? Now, there are some terms, there are some things that you have to recognize and terms that you have to know to be able to do this. All right? And then I'm going to show you how. It's actually not that, it looks really complicated, but once you get the hang of it, you can do it the same way each time. Okay? The first thing that we need to talk about is something that you really don't talk about, I don't think, when you're in like the middle school, is what a proper fraction is. Now, everybody knows an improper fraction. You've done that before a lot of times. But a proper fraction is a fraction whose denominator does not divide into the numerator. And I'm going to give you ERATOR. And I'm going to give you some examples of a proper fraction. So these are all proper fractions. 8/9, 1/2, 4/7. Okay? Because 7 doesn't go into 4, 9 doesn't go into 8, 2 doesn't go into 1. All right? When you learned them, when you were back in middle school, you learned all about improper fractions. So like 10 over 3 was an improper fraction, and then you learned how to write it as a mixed number. Because 3 went into 10 3 whole times, and then there was 1 left over of a part of 3. So that's 3 1/3 is a mixed number. This fraction is improper because 3 goes into 10. These fractions are all proper because the denominator doesn't go into the numerator. Now, it also works algebraically. So these are all numeric proper fractions. Here are some algebraic proper fractions. 4 over x is a proper fraction. 3 over x minus 2 is a proper fraction. 4x plus 1 over x squared minus 3 is a proper fraction because x doesn't go into 4. X minus 2 doesn't go into 3. X squared minus 3 doesn't go into 4x plus 1. The degree on the bottom is larger than the degree on the top. This is degree 1, this is degree 0. This is degree 1, that's degree 0. This is degree 2, that's degree 1. Okay? All of these are also considered to be proper. So the first thing you have to understand is that when you write your partial fraction decomposition, your fractions have to be proper. Okay? They have to look like this. You can't get a fraction when you're done that looks like 4x over x plus 2. That's not proper because x plus 2 goes into 4x. They're both degree 1. Okay? The degree on top has to be smaller than the degree on the bottom. And that's one of the key things that you need to understand to be able to decomp fractions. All right? What makes a fraction proper? Okay, so now to do this, you're basically going to follow a set of steps, which I'm going to show you. Okay? Number one, the first thing you should do is factor the denominator. If it can be factored, you should factor it. All right. Step 2, you're going to write possible fractions that your single fraction can be broken up into. I'm going to show you how to do that momentarily. Okay. Number 3, you're going to find the common denominator and find the missing values. Okay, and then finally, step 4 is you're going to write the decomp. You're going to write the fractions that you get and say, that's my final answer. These are the fractions I got. Okay? All right, and I'll show you how to do all these momentarily. Okay, so we're going to start by setting up some partial fractions. So let me show you what that's all about real quick. So I'm going to ask you to set up. I'm not going to ask you to find the partial fractions. I'm just going to ask you to set them up. So let's start with how about 3 over x squared plus 4x. So this is a fraction. I want you to break this fraction up into fractions that could be added to get this fraction. So you do that by doing this. You're going to factor your denominator. Okay, there's a GCF there. Now, this is the common denominator, x times x minus or x plus 4, which means that if I were going to break this up, then it's certainly possible that one of my denominators would be an x, and the other denominator would be an x plus 4. Okay, if I were going to break the two fractions apart. Because if I wanted to put these two fractions back together again, the common denominator would be x times x plus 4, which is the correct common denominator. Now, in the numerator, we have to decide what to put there. We don't know what to put there. Okay? We know that we want the answer to be a 3 when we're done, but we don't know how that's ever going to happen. So we don't know what is going up here, but we do know something about what has to go up here in the numerator, because these fractions have to be proper, which means that if this is degree 1, this factor is degree 1, it's an x, then the only thing I can put on top is a number, which would be degree 0. But I don't know what number, so I'm going to call it a. Okay? This other fraction is also degree 1 in the denominator. It's an x plus 4 as its factor. So for it to be proper, the only thing that can go up here is a number. But it doesn't have to be the same number as this one. So I'm going to call it b. Okay? That's how I set up my two partial fractions. Now, I actually haven't figured out what A and B are yet. I haven't showed you how to do that. Okay, I'm going to do that in a minute. But that's how you set them up. And that's as being able to set it up is as important as being able to actually decomp it. Because if you can't set it up right, you're not going to be able to decomp it correctly. All right. Okay, so let's try. We're going to set this one up also. We're not going to solve it. And then we're going to go solve the one that we did at the very beginning of the video. So let's try to set up 4x plus 1 over, I'm going to write for you the factors. Let's try, the factors are x, 2x minus 5, and x plus 1. Okay, there you go. There's your denominator. So now, if you look, the denominator has 3 different factors. It's already factored. It has 3 different factors in the denominator, which means that there are 3 possible fractions that I could decomp this fraction into. One of them could have a denominator of x. One of them could have a denominator of 2x minus 5. And one of them could have, let me see if I can sneak it in here, a denominator of x plus 1. Yeah. Okay. So there's now 3 fractions that are being added to make this one fraction, potentially. Now the question is, what goes on top? Well, this is degree 1. To make it proper, all I can put up here would be a number. So I'll call that number A. This is also degree 1, 2x minus 5. It's linear. So on top of here, I'm going to put B. There has to be a number up here, but it doesn't have to be the same number as this. So I'm going to call it something different. Up here, again, degree 1 on the bottom, doesn't have to be the same as either of these. So I'm going to go to the next letter in the alphabet, and I'm going to call that C. All right? So now I have an A over x plus B over 2x minus 5 plus C over x plus 1. Now, I don't know what A, B, and C are. I have to figure that out, which we're going to do in the next example. We're going to show you how to get these numbers. All right? But that is how you set them up. All right? Now, what I want you to understand is this. You can't put an x up here, because if you were to put an x up here, let's say, then the bottom would go into the top, right? X plus 1 could divide into, you could do long division on x plus 1 into cx. You could do that. Okay? You could figure out what goes up here. It would be a c. It doesn't matter what it would be, but it goes in. So it's not proper. So that's why you can't have an x up there. You can only have a number up there. All right? Okay, but we don't know what any of those numbers are. All right, so now let's try one where we're going to go through the whole scenario. All right? It's going to seem like a lot the first time. I promise you, the good part is, okay, once you get the hang of this, it's done the same way almost every time. So I'm going to try to decomp this fraction. Now, there's a good chance I'm going to have to erase some of what we have here and later on, because I'm going to run out of room. All right, I want to decomp this fraction. So first thing I'm going to do is factor the denominator. So I could factor it, x plus 2, x plus 1. And now I'm going to set up my fractions. Well, one of the factors is x plus 2. The other fraction is x plus 1. Now, you may also be thinking, how come he's always writing plus? I always write plus here. Okay, you always put plus in the middle of your factors, and then if one of the numbers comes out to be a negative, you can change the plus to a minus. Okay, so in the denominator here, I have degree 1 on top. I can put a number. I'm going to call it A. Then over here is degree 1 on the bottom. I can put a number up here, but it doesn't have to be the same as this one. I'm going to call it B. Okay, so that's the setup part, right? We've done that before. All right, now, next step. What you're going to do is you're going to re-find a common denominator, which basically I already did, okay, using these two fractions. All right, so you're going to actually work this problem out as if you were going to go find a common denominator and see combine the like terms, or well, you're going to find a common denominator. Okay, so the common denominator here would be x plus 2 times x plus 1. So that would mean the first term would have to have an x plus 1 on the top and on the bottom. All right, and then, oh, that says plus 1 there. I know it's hard to read. And then the second term would be an x plus 2. That's a plus 2. All right, let's try that again. That's a plus 2. There we go. On the top and on the bottom. Okay, x plus 2. All right, x plus 2 on top and bottom there. I know it's cut off. Okay, so now what you'd have is this. So we're not going to clean the whole thing up. The denominator would be x plus 2, x plus 1. The numerator, I'm not going to distribute. Okay, there's a reason for that. I'll show you in a minute. Would be a x plus 1 plus b x plus 2. That's what I get. Okay, now let me go back and show you. So if I refine the common denominator, I get this. I want this to be equal to this, right? This is what I want. Because if I find a common denominator, then this should be my answer. So this should come out to be 7x plus 11 over x plus 2 times x plus 1. All right, that's the only way they'll be equal. Now, if you look, the denominators are already the same, but the numerators are not. All right, so here's what I'm going to do. I'm going to have to erase the stuff that's up here at the top. All right, so here's what I'm going to do. I'm going to go back and I'm going to rewrite my numerator here. I'm going to write 7x plus 11 over x plus 2, x plus 1. Normally we see that on the left and then this on the right. It's just that I don't have a lot of room on this board, so I'm going to try to write it the way that you would normally see it. So this is what you got. Okay, so the denominators are all the same, right? They're exactly the same already. The numerators are not. But you know that the two numerators should be equal to each other to make this work. So 7x plus 11 has to equal a, x plus 1, plus b, x plus 2. Okay? The whole numerator has to equal itself. Both numerators have to be equal to each other. Now, what do you want to know? You really want to know a and b. Because if you know a and b, you know the two fractions. Okay? If you look back at your work, I know I erased it. Let me see if I can fit it in here. I don't know if I could fit it. Yeah. Might be able, no, I can't fit it. Okay, so we'll go back to it at the end. So I need to know what a and b are. So what we're going to do is we're going to use a method called the heave aside method. So by heave aside, right, like throw something away, throw something out. So what we're going to do is we're going to pick strategic values of x so that we throw out one of these variables, and then we'll have the other one left to solve for. So for example, okay, I'm going to let x in my equation here be -1. Now, why is that good? If I let x be -1, I get 7 times -1 plus 11 equals a, -1 plus 1, plus b, -1 plus 2. So this is good because -1 plus 1 is 0. 0 times a is 0. That means a is gone. It's not in this equation anymore. I heaved aside a by letting x be -1. So now I can solve for b because b is the only variable left. So I get -7 plus 11 is 4. 4 equals 1b. So b equals 4. Okay, that's good. I know b equals 4. All right, now I'm going to erase this because I don't have a lot of room, like you guys can see. Normally you just do it next door or something. Now I got to pick another value for x. So in this case, I would pick negative 2. Because now I want to heave aside or throw out b. I want to zero out b. If I can zero out b, then a will be the only variable left. So that's what I want. So now I have 7 times negative 2 plus 11 equals a times negative 2 plus 1 plus b negative 2 plus 2. But negative 2 plus 2 is 0. So that's gone. So now I have negative 14 and 11 is negative 3 equals negative a, right? Negative 2 plus 1, negative 1. Negative 1 times a, negative a. So negative 3 equals negative a. So a equals 3. So now I know a equals 3. Okay, there's my b, there's my a. That's what I need to finish this problem. So now if you go back to your original, okay, if you go back to the original decomp said a over x plus 2 plus b over x plus 1, then I know a is 3 and b is 4. And this is the correct answer. I can decomp this into these two fractions. But you already knew that because it's the first problem that we did about 20 minutes ago on this video. We combined these two fractions to get this. So now I just showed you how to go in reverse to go backward. Okay? The reason we do this, I'm going to do another example with you in just a moment, but the reason we do this is because there's a method in calculus called integrating by partial fractions, right? Where you have to actually take a fraction. Integrating is an operation in calculus, where you have to take a fraction and you have to, what we call, decomp it, okay? You'd have to take that fraction and write it as its two separate fractions so that you can, in fact, do the operation of integration on it. That's why we do this. Okay? All right, and this is pre-calc, so there you go. All right, let's try this one. Same idea, okay? Like I said, it's a bunch of steps. First thing you do, factor. X minus 3, x plus 2. Keep the x plus 7 on the top. Now, decomp the fraction. So I got to write my two fractions that I'm going to get. I'm going to get an x minus 3 is one factor plus x plus 2 is the other factor. Okay? I'm going to put an a on top of here and a b on top of there because they don't have to be the same. Now, you're going to refine a common denominator. So let's refine the common denominator for this with a and b. So we get a. We'd need an x plus 2 for this one and an x minus 3 for that one. So we'd have a, x plus 2 plus b, x minus 3 all over x minus 3 times x plus 2. Okay, that's my common denominator. And that's equal to x plus 7 over, let's see that. So x plus 7 over x minus 3 times x plus 2. Now, what do you want? The denominators are already equal. You want the numerators to be the same. So for the numerators to be the same, you would have to have, well, let's just do this. Let's just erase the denominators. And now I want the numerators to be the same. X plus 7 to be equal to a, x plus 2 plus b, x minus 3. Now we're going to pick values of x, be smart about it, so that you get either a to 0 out or b to 0 out. So let's pick negative 2. Okay? If I pick negative 2 plus 2 is 0. 0 times a is 0. So I'll get negative 2 plus 7 equals b negative 2 minus 3. So that gives me, let me see, that gives me 5 equals negative 5b. So b equals negative 1. Okay, so b is negative 1. I'm going to write that up here. I'm going to need it in a minute. All right, that's good. And then over here, I'll do it. I'll let x equal, okay, so now I want to get b out of there so that a is still left. So I'm going to pick 3 for b. 3 minus 3 gives me 0. So that'll give me 3 plus 7 equals a, 3 plus 2. So 10 equals 5a. So that means a equals 2. So that means a equals 2. There's my two numbers that'll make the partial fractions. So what I have is, if I go back to this step all the way back up here, I'll have 2 over x minus 3 plus negative 1 over x plus 2. And then what you can do is, see, since the second one is negative, you can turn it into 2 over x minus 3 minus 1 over x plus 2. So that's how we get subtraction in between them, even though we always start with addition. Okay? And this is the correct answer. So what I'm saying to you is this: if you find a common denominator for these two and combine the two fractions, when you are done, you will get x plus 7 over x minus 3 times x plus 2, which is what we started with after we factored the denominator. Okay? That's what this is all about. All right? Trying to take a one fraction and turn it into all of the fractions that I can put together that would make that one fraction if I combine them. Okay? All right, there's a lot more to come on this. This is only type 1 of partial fractions. There are actually 5 types. So this is type 1, plenty more to go, but we're going to have plenty of practice along the way. Okay? But these are at least the steps that you can follow. All right? Thanks for clicking. I hope you enjoyed this video. Sorry it ran a little long, but I hope you learned something. Have a great day.